Ready, Julian.
Yeah. Hello, everyone. Welcome to this session of Let Us Talk It webinars. We always appreciate anyone who joins us, and we hope that we add some value to your everyday life. And if we do so, please don't forget to comment, give your feedback, or just write a friendly email at webinar@letustalkit.com. Absolutely, it started with knowledge as a knowledge sharing platform to make an empowered and informed community. And if you can join hands, nothing like that, we can make a better community, an informed community, definitely. So for these webinars, we do every week, Tuesday, Wednesday, Thursday from 12 to 1 p.m. EST. And these are professional webinars related to work and life. And on Fridays, we do our youth webinar from 4 to 5 p.m. EST. Definitely, those are also, empowering our youth to be out and more outspoken in their thoughts. And these youth sessions, they are a trained session. So these youths are guided and they are given training every Tuesday and Wednesday from 4 to 5 p.m. EST as well before they present to you. So they do work hard for this. And that's how our webinar sessions go. But if you want to be a guest speaker, or if you want your kid to be part of the youth webinars, please do email us at webinar@letustalkit.com. And having said that, we begin our webinar today. We are extremely excited, and there is some, I think, confusion with the topic, but let's get everything straightened out here. The topic for today is CNN architectures, image processing, and improving the prediction accuracy of the custom CNN models. So that's the topic. And we have a very interesting and young speaker today. And when I approached him, he said that he was not that confident if he is fine with having the webinar, but as soon he heard all of it, and what I got the understanding, and that he is very passionate about the subject, and it doesn't he doesn't keep believe in great degrees and things like that, but what he feels and what he likes is what he does. So nothing better than that. We have with us our young guest speaker, Manthan Ladva. He learned machine learning and Python on his own, and he refers hands-on machine learning with Scikit Learn and TensorFlow book by Aurélien Geron, which is one of the best books for machine learning, is his suggestion. And Manthan also loves exploring computer vision field, as self-driving cars motivates him to explore image processing and CNN field. And earlier he has given seminars in his own hometown community, in Google Developers Group, and in getting started with CNN. He does practice in Kaggle for machine learning to sharpen his skills, and he loves contributing in community by writing blogs, giving talks, and making projects. And his hobbies are reading books and exploring new places. We are extremely glad, Manthan, that you tried to explore this webinar, and you agreed to be a guest speaker. We are extremely honored and happy to have you. Over to you.
Thank you, Julian. Thank you for having me. Can I share my screen now?
Please.
Thank you. So, good morning, good evening, good afternoon, everyone. Namaste. I am Manthan, and I will present CNN architectures. So, yes, one of our fellow participant told that CNN is also a news channel, but here CNN is CNN related to image processing in machine learning field. So I am here. I think I cleared that one small doubt, and let's get started. Today's agenda is um, quick warm up. So I will give a quick warm up to understand all the architectures which I will uh, speak over here. Second is what is CNN architecture actually, and different kinds of CNN architecture. So today's very small agenda, but different types of CNN architectures is very vast. So let's get started. So quick warm ups. First thing, what is padding? Padding is what say if you have one image is how can one computer grab the information from image by taking its pixels. So let's assume that this is a box of image, and here you have one whole image, and its small boxes are is 1 pixel each. Okay, so now assuming that it is an image, sorry, it is an image. uh, if we are putting our if we want all the information of this image, we have to put one padding layer. Padding layer is nothing but one whole completing the whole border with 0 pixels, so that we get the whole image of that information of that image. So this is padding. Another side is pooling. Pooling is nothing but it is dividing the whole image uh, by it's dividing whole the image by 2. For example, let me be clear. For example, here I got one example where you will see here we have two types of pooling: max pooling and average pooling. By name it defined itself. Max pooling is nothing but taking let's assume that this is a red box, and red box has maximum 6 number over here. So 6 is the 6 number, it will grab it and put it over here. So this is the pixel. 6 number is the pixel, highest number pixels maximum. So it will take over here and leave it all other in its place. Okay, so likewise it will do all the three there. So it will divide whole the image by 2. Here we have 4 cross 4 image, now it will divide 2 cross 2 image. Okay, so it is dividing whole the image by 2. It is maximum max pooling called. Now if we are talking about average pooling, then it will take whole average of all the numbers and divide it by 4, and it will do the same thing. So in both the way, pooling is nothing but taking 4 cross 4 image to 2 cross 2. So it is dividing by 2 by taking mm, necessary information and giving further. This is pooling. Another is stride. Stride is nothing but jumping from 1 pixel and leaving 2 pixels between and going further. This is called stride. I'm not going deep right now in this because it will take a lot of time. So I'm giving just an informative about strides, pooling, and um, padding. Now, what is CNN architectures? So let me clear. I am assuming that you all know the meaning of architectures. Architecture is nothing but creating. Architecture is mainly used in civil areas. I think so. So architectures mean creating a building. Okay. So in here in CNN architectures, we are using blocks for building a neural network. So as you can see, we have many blocks, many small blocks, which are creating a whole architecture. So this is what CNN architecture is. Now we have different types of CNN architectures over here according to year which they were published. So we have LeNet 5, AlexNet, VGG16, Inception V1, Inception V3, ResNet 50, Xception, Inception V4, Inception ResNet 50, and Next 50. So we have total 10 CNN architectures which are widely famous in giving best accuracy till now. Let's get over one to one. and learn what is the difference between all this. Okay, so first one is LeNet 5. LeNet 5, the one who give this LeNet 5 architectures was to Lee Kuhn. Lee Kuhn was the one who had given this architecture. So he given its name as LeNet 5. Sorry. LeNet 5 has three convolution layers, two fully connected layers. So we have total five layers over here, which is giving 60,000 parameters. So you can see over here that first it is taking image of 32 cross 32, and after the first convolutional layer, it gives the image of 28 cross 28 after one pooling layer, and after second convolutional layer, after one more padding and third convolutional layer, and we have two fully connected layers. So this is what it says, that this is the very basic what say this is the very basic neural network at that time. When in 1998 LeNet was came, it is the very basic, and it is used widely in numerical and handwritten digits related projects. Let's get to another level. Second one is AlexNet. AlexNet is AlexNet is made up of five convolutional and three fully connected layers. So it have total eight convolutional layers, which have 60 million parameters. So I will say that AlexNet is expanding LeNet 5 layer. LexNet is expanding LeNet 5 architectures. So as we go back, we will see LexNet was LexNet used convolution layer of 11 cross LexNet used 11 cross 11 layer. After that, using max pool 3 cross 3 layer. After that, again convolutional layer of 5 cross 5. Then again max pool of 3 cross 3. Then now you will come over here and you will see that it is using 3 cross 3 three times. So AlexNet was the first one who came with this concept of giving two or more than two convolutional layer at a time, without putting any max pool layer between them. So after giving these three layers of convolution layer and one this max pool layer, this is used here to reduce the dimensionality of the image. And after we have three fully connected layers, in which the last layer, the last fully connected layer uses softmax to predict. And now you can see over here that it is the first one to implement ReLU activation function in all the layers. ReLU activation function is nothing but it gives the positive answer or zero. It do not goes in a negative. Like it gives, if you have more than one as an answer, then it will give that answer, or it will give zero, but it will not give any negative answer. So that is what ReLU does. Its full form is rectified linear unit. So it will give positive answer. So AlexNet was the first who implemented ReLU as activation function in all its layer. Third is VGG16. Sorry. VGG16 also came with AlexNet's idea, but now you will see over here that convolutional layer have 11 cross 11 of layer and 5 cross 5 of layer. But in VGG, they are coming with 3 cross 3 and max pool of 2 cross 2. So they came with this unique idea that let's go with very small height and width of convolutional layer, and it will give more accuracy. And they were right at that time. So they have 138 millions of parameters. They have 13 convolutional layers and 3 fully connected layers. So you can count like this. Just count 2 red box which are convolutional layers, and there are 2 here 4 and here 9. So 9 plus 4 13. So 13 convolutional layer and 3 fully connected layer, which is softmax for predictions. Okay. So this is giving 138 millions of parameters. So now they were it was the idea behind using this was idea behind using this was they were very in, they had taken decisions in all the corners and came with that, let's go with small and we can get more accuracy in it. So here you can see they were coming with larger hyperparameters over here, and which gives more parameters 60 million. But here where they gone very lower and also get many more parameters over here. Fourth number is Inception-V1, or you can call it Google Net. Why? Because it was this idea and this concept was came by Google research team. So as names define itself, I hope you all have watched the movie of Leonardo DiCaprio, that Inception, which came in 2010. So as you can see in screen, it is written that's not enough. We have to go deeper. So yes, till now you had gone idea that as we go further and explore more architectures, the layers will go deeper and deeper, and we have to understand why it is going deeper. So at the last, when you go, for example, you have an image of 32 cross 32, or let's assume that you have image of 200 cross 200. But this neural networks divides its image and go with very small particle, very small, not particle, very small pixel of it, and it takes that as a information and do its prediction. So by 200 to 200, it goes lower, 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 and divides its image with pixels, and it go very lower and grab that information and do the prediction. So this is what image recognition, or you can say computer vision field is. So here we are talking about Inception-V1 given by Google Net, which have 22 layers of architectures and 5 million parameters. So Inception was really and in the movie Inception was going deeper in their dreams. So GoogleNet had taken this idea and given this name as Inception. The what is Inception is, so when we have, let's assume this here is an image, and when you give an image of a layer of 1 cross 1, so the image do not get any type of what say the image do not get any type of informations from it. But when you give it 5 cross 5, it will take its reaction and give some information. So they had did this same. So they had put this 1 cross 1 image over here. Was the idea behind this putting over here was to reduce the dimensionality. So 1 cross 1, 1 cross 1, and 1 cross 1 over here. Here also is 3 cross 3 max pooling. Now anyone can ask me a question like why we have put max pool over here. It is a convolutional layer. So yes, max pool is put it over here. The reason behind is to give the whole neural network in a smooth way, because we are using this box 9 times in further slide. I will show you how. So we are using 1 cross 1 over here, and after that we have 4 results, one of this, one of this, third and fourth result. Now at last we will concate it. So we will not concate, they had concated it, and they will give output of this. So yes, we had gone deeper in this, and now I will show you how this came. So that image is over here. This is called Inception module, and this is a STEM module. STEM module is nothing but the initial stage of giving image of convolutional and max pool layer, which will be set over here. So input stem, which is this, and now we have gone in inception multiply by 2, so we are giving two inceptions over here. Then again max pool 3 cross 3, again inception 1, again now you will see that you there is a branch and which have two fully connected layers, and last is a softmax layer as it is written here as, so it is softmax layer which gives the output. Now anyone can ask that why it is given, why the branch is taken over here. So the idea behind this was to uh, take the hidden layers of the data and predict that they were going right or not. So they had took here the branch, and they had assumed that this will go the right, and they had predicted over here. Same they had did this over here also, and inception module over here taken three layers of inception module, and they had again trained it and tested it that is it going good or not. Same things were gone further also. Same taken over inceptions, then agar max pool, again inception two times, and then average pool. Average pool, you can see average pool's layer is of 7 cross 7. So you can so now again anyone can ask me why average pool is 7 cross 7. So after training with this large number of convolution neural network, uh, it is over here to sum up all the ideas and give a global pooling layer. So it is called global pooling layer, which sum up all the ideas, all the information, and go smoothly in the softmax layer or fully connected layer. So this is inception module. Sorry, inception layer. Now fifth was inception V3. Inception V3 is none other than taking the idea of inception V1. Now again anyone can ask why inception V1 and V3. So the logic behind this was when inception V2 was coming with its unique idea of exploring more in V1 and giving more layer to V1, but there were some tweaks which were solved in inception V3. So inception V2 was not considered as successful, and inception V3 was coming with good. So they were come over here with inception V3. So iPhone 8 and iPhone 10, there is no iPhone 9, so I don't know that story. But here is, I do have story that why inception V2 is not available over here. So Inception V3 explored Inception V1 or Google Net. Let's call it Google Net, so it will be clear. Inception V3 also came by Google, and they had explored it with giving more modules over here. So they had taken over Inception in module 1, module A, module B, module C, and reduction modules for smoothing the flow of doing this training this neural network. Okay, so here we have input, the stem which I had discussed over here. This is what stem is. Inception A for 3 times, then reduction over here, then inception for 4 times, reduction B, inception for 2 times, and yes, after that we have stem also, which will train it and test it the more that is it going right or not. And after that global average pool, which I had discussed over here, why it is 7 cross 7 and why it is called global average pooling layer, because it also gives you uh, it also smooths your layer and gives the awesome output. And this is at the last is softmax layer. Sorry, this is what softmax layer is, which gives the perfect output after training this large number of modules. So this is what Inception V3 is. Now ResNet. After studying this 5 In CNN architecture, ResNet is the one of the most highly accurate CNN architecture till now. Because ResNet is coming with very unique concept of skipping the steps. Means giving the accuracy by skipping the step. I remember when I was doing my maths, my teacher won't give me marks, but here we are giving good accuracy by using ResNet 50. So ResNet 50, what it do? Let's concentrate over identity block and convolutional block. So you will see here that identity block, when your data is coming over here, and when it is directly passing and giving add button over here. So what is add? It will do nothing but skip the between three steps and add your data at the last of it. So uh, at initial stage you won't have any information. So what you are giving, the input, the what you are giving, the image itself has its information. So let me crack this. Suppose you are giving it an image, and the computer do not have any memory of what you are giving. So what you are giving is itself is an information for him. So that is what ResNet is doing. ResNet is skipping between steps and direct jumping to this add button, which will suppose that you are giving information is the information you are giving, the image is one of the information which ResNet is uh, wanting right now. Okay, so this is what ResNet is doing. This concept is called residual network, in short ResNet. Okay, now you will see our convolutional block. Here also you will see that one cross one, this is the inception module over here, one cross one and one cross one. After that they are also adding over here. So putting this both the thing in main network, you can see 7 cross 7 after 3 cross 3 of max pooling. Then you will see here convolutional layer, which is this. After see you will two identity blocks, again convolutional, three identity blocks, again convolutional, five identity blocks, again convolution, two identity blocks, again average global average pool layer. Okay, and after that softmax layer. So why it is famous? It is famous for skipping the steps, skip connection it is called, or you can say shortcut. So now again, from audience, anyone can ask me this question, that why skipping step and gaining more accuracy or giving the more high accuracy. So it is like what you are so after skipping the between steps, the what you are giving it itself is an information for the computer. So after repeating these steps, like here two times, here three times, here six times, oh sorry, five times, or here two times. So after doing this much after repeating this much times of steps, the computer learned that, or our network learned that you are giving the information is the what they want to predict. So this is the concept behind this residual network. Hello, am I audible? Oh, sorry, sorry. Okay, and there is one batch normalization, and ResNet was the first one who came with this batch normalization concept of using the batch normalization in this ResNet. And now you will ask why ResNet 50. So this is coming with 50 layers, so it is called ResNet 50. Another, we also have ResNet 34. Now I also read one that ResNet 150, ResNet is made up of sorry, okay, ResNet is made up of 152 layers. So ResNet is that level highly accurate architecture which gives more accuracy. So ImageNet always comes with a competition, like give your architectures, and let's trade in and test it, and give take we will do some research on it, and we will so they can come to know that how much your architecture is accurate. So ResNet 50 was the first one who gave only 3% of accuracy. 3, sorry, not accuracy, 3% of error, 3.6 around of error, which ResNet give. So that much level of talented ResNet architecture was, and it is most accurate while I was using in my project also. So yes, this is ResNet 50. Now I'm coming with Xception. Xception is nothing but extreme level of inception. That is what Xception means. Xceptions coming with 22 layers of architectures and 23 millions parameters. 23 millions of parameters. So what they are doing over here is using convolutional A block, convolution B block, and convolution C block. They are just adding and concatenating and putting the all the sum of things over here and making the architectures. So what we learn far till now, the all the networks are used again and again, and after taking some of the change, after giving some of the changes, they are using same networks again and again. So Xception is nothing but changed version of Inception. They taken 3 blocks over here, putting over here, and after taking global average pool and softmax layer. Inception V4. Sorry. Inception V4 is again same as Inception V3, and we have here 43 millions of parameters. Inception V3 is, we have here Inception A, B, C, reduction of 2, and stem step over here, which we are using over here. So you can see that Inception A, B, and C are far more changed layer in it, and given it in the neural network. So this is what Inception V4 was. So now coming Inception and ResNet V2. It is also same as Inception as ResNet. Inception and ResNet. Here you can see 3 layers and 2 and 1 over here, and this all gets concatenate over here, and after that we will doing adding. So this is what Inception and ResNet both combined over here. So we have stem Inception A, Inception ResNet A, reduction A, Inception ResNet B, reduction B, Inception ResNet C, and convolutional one, global average pooling, and softmax layer. So there was nothing, just using Inception as ResNet to both the architectures and one place, and changing some of its stem branches and using it further and giving more accuracy. It is coming with 56 millions of parameters. The last one is res next 50. So what is the changes in ResNet 50? Res next 50. So ResNet 50 was coming with 25.5 millions of parameters, and here we are here ResNet 50 is coming with 25 millions of parameters. Now you had seen back over here in ResNet 50 that convolutional blocks and identity block is quite small and giving good accuracy. But here you will see that it is coming with very large and extreme amount of convolutional block as well as identity block. So the both will put in the main neural network and perform the architectures, and after the softmax layer, taking after taking global average pool, it will give softmax layer. So this is what as you go and as you expand more the architectures, the more you will go deeper and deeper into it. You will use more convolutional layers, you will use more Inception module, residual networks, and for increasing your accuracy and predict the good results. So this is what ResNet 50 was, which gives 25 millions of parameters. So this is all from my side. Thank you. Any questions far till now? I will be happy to answer.
Yeah, thank you, Manthan. Yes, any question, comments? Raj would want to hear your comments, the topic that you thought and the topic that is. So, any comments on that?
Yeah, it was a very technical topic, whereas I was looking at it more from the common man's viewpoint. Okay. So, from anything that any person talks, you can gain a point or two. If you have an open mind, you can learn from almost anything that you hear. Okay.
True said.
So from that viewpoint, I learned some technical terms and how does it operate, etc. So definitely it was useful.
Glad you liked.
Thank you so much. Thank you.
And then I have a question. It may be rather dumb, but I'll go for it anyways. Regarding padding and pooling that you showed on the very first slide, I'm very new to this, so I was trying to understand why any image processor would perform these processes. What is the purpose?
Okay, so let me show you again it, which after that it will be more clear to you. So let's understand it is an image of your own self. Okay, so we have you had seen over here that this is a convolutional layer, and it is taking a small part of here. Okay, so the convolutional layer is nothing but 3x3 layer. So while you are putting 3x3 in this 3x3 over here, let me show you, let me demonstrate you. So let's say you are taking here some results. Sorry. So let's understand that now you are having a 3x3 layer, which will be setted in this. Okay, so now it will be setted in this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the image processing will come with 3x3 layer. So if we put over here, it will grab only this middle 5 number information. So what is set in this pixel, which I had given the number 5, it will take only that information. So for example, if you just don't look the 0 border over here, you will get this 5 number only. But what if I want this 1 number? What means what if I want this 1 number information also to me? So I had put it the 0 padding layer over here, and now you put the 3x3 layer. Let me show you again. Sorry if I am taking more time, but so let's say now I am taking this much of data. So now you assume that I want 1 number of data, and in convolutional layer it will take the, if you put 3x3 layer, it will take only the middle one of this. So here I can also get this 1 number of data. So this is the logic behind taking the padding layer, using the padding layer. This is what the logic was. And pooling layer was just to divide your image into half and take the necessary information from it. So pooling is of two types, max and average pool, which I told earlier. So max pool takes maximum number of information here and take it over further, which I had taken for demonstration. I had given number and taken this data. In average, it will sum up and divide with 4 and do that, which in architecture I had shown you global average pool. So this is what average pooling do over here. Now next is stride. So stride is nothing but it just skip it. So we it gets very smooth to take and get more information at a time. So it won't get very hard to use neural network. So that's why stride is used.
Thank you, Madan.
You're most welcome.
Yeah, there was one more question. Can convolutional neural network be applied for satellite image classification for feature extraction?
Yes,
From
sure.
Deepa.
Yes, it is also used in satellite also for using most, giving most of the output. So I am taking a random example like uh, some years back, there was a very trending picture in the internet, in mostly in Twitter, which I use most. So in Twitter, I came to know that scientists searched the black hole. The black hole picture, which was searched by NASA, or I don't know from where, but it was searched by using machine learning. So machine learning in this was very 5 to 6 such libraries which was used, and taking all the information and giving such output. So it is also it is also used in taking the data from satellite and giving it back to the earth. So I think I'm giving right answer or not, then please repeat the question again so I can be more clear.
Hi, it was from me. My name is Deepa.
Okay.
Basically, I'm from the GIS field. So I was just wondering if this technique can be used to capture the, to classify the satellite image and extract the features such as roads, buildings, water bodies.
Oh, okay, okay. So I got your question, but I'm not much more aware about how it is applied in this field, because I have and I don't know about it. But somewhat I do have a hint of it. Like if we use the Google Maps, yeah, everyone were using Google Maps. So they were coming with one filter which will gives you the red light area, or which have more traffic jams. So this is all the filters where came up from the satellite, which gives you direct live location of how much traffic is over here, where they were also using machine learning and capturing the data by while seeing from the satellite. There this is congested over here, so let's give it a red light. So by just putting one button on, they came we can come to know that we have different types of traffic over here. This is clean and this is congested over here. So I think they came with this idea in taking this as
Is I think there has been some technical issue. Okay.
Manthan, I think you are on mute.
Yeah. Manthan, can you unmute yourself?
Oh, yes, I did. Sorry.
Yeah.
So any more questions from your side?
Deepa, did you get your answer? Whatever you were asking?
Yeah, to some extent.
Okay.
I'm sorry if I was
Thank you.
not more clear about your
No
answer.
problem, no problem, because that's a totally different subject. But when I heard your explanation, I was wondering whether that can be applied to satellite image processing.
Okay. Thank you.
Yeah, thank you. Thank you so much.
So any more
Manthan,
questions?
yeah, I have two questions, Manthan.
Yeah, sure. Please go ahead.
Yeah, firstly, like I would like to thank you. It was a nice presentation, and I think from a
Glad you
machine
like.
learning point of view, it's too technical from architectural wise, and having a lot of processes. I have learned so many things in this. I mean, like I came to know about this. So the first question would be like in a self-driving cars, behind the
Yes.
scene, the machine learning plays a big role, right?
Yes, true.
Okay, so in the self-driving, like when the car identifies the pictures, okay, like humans, other bikes, and the stop signs and signals, everything. So how fast is it calculating while it is driving? Okay, I know this is all the architectural process will be happening, like how it runs in our brain. It should happen somewhere in the car, okay, and take a decision to move forward, take right, left, stop, go slow, right? So in this situation, how fast is that process will be going on?
So
And what?
let me, yes, please go ahead.
Yeah, no, that's it. Yeah, please answer.
Okay, so let me give you idea like this, that when we are driving car, let's divide the whole scenario into three parts. One is pedestrian area, one is car or any of the vehicles coming over here. Let's say four wheel car or any more than four wheel is coming in front of our car. Okay, or another is bike. So we have the three different uh, we have three different categories, which all the things it is divided. Okay, so they are coming with sorry, they are coming with different maths and different logic, that all the things which is looked in front of our eyes or in front of our car's computer, they will divide this and take a quick decision on it, that now we have to brake, or now we can increase our speed at one level. Another car is passing by, so we have to slow down our vehicle. So this is what uh, computer vision is used over here. The sorry, the logic, or you can say no, not architecture, the algorithm used behind this is called YOLO, you only look once. The name itself gives the definition of it. You only look once. When you looked once, you can come to answer that now we have to speed goes down, or we have to increase the speed. So the algorithm used over here is called YOLO, and which is also interests me the most to explore. So I was able to answer a small answer to your question. So this is what your answer, you want this answer, or?
Yeah, that's fine. Yeah. And the second question related to this similar thing. Suppose even sometimes when we are driving, right? So if there is a stop sign and there is a tree in front of that with branches and all, and if we can't find the stop sign, right? And we know generally it's a four road section and we have to watch and go on. Okay, so even if that four roads are coming, yeah, even the car will be knowing that it is an intersection. Okay, so you have to slow down and move on. But if it is basically on the pictures of stop signs where you are saying like pulling and padding all those things, So if it is, if as a human eye is not observing that sign because of the branch which is not showing the sign, okay, how does that can be calculated by a self-driving car? And because of that, will there be any accidents?
Okay, so when I was exploring Elon Musk book, they were coming that they had taken lots of, they had put their lots of efforts in improving their software. So I think their software, the software which you said that we were using padding over here or pooling over here. So here also YOLO algorithms comes in a role, and it also it also takes the information which and all time I all time believe that computers and the algorithms which were made are far more better than our normal usual eyes. Okay, so this is what that if we are not able, sometimes there were branches, or I think there will be, I don't know how they will come with this answer, but your problem, you came with this question is quite interesting for me also. So right now I do not have any particular answer that how they will come with this problem solution, or they will not make any accident. But yes, I will come again back to you and give this answer by sure. But your
Okay.
this question was quite interesting for me as well. So sorry, can I know your name, please?
My name is Nagendra.
Nagendra. Okay. So after getting me this answer, I will definitely come back to you.
Thank you.
So any more questions?
Yeah, exactly. This is what we want to achieve on this platform of Let Us Talk It, that we can exchange our ideas, what we know, what we don't know. And yes, the communication should carry on. Thank you, Nagendra, for your question. Any more questions or discussions that we can have? Okay, before you think of any more questions, I would just like to remind that we have these Let Us Talk It webinars every Tuesday, Wednesday, Thursday from 12 to 1 p.m. EST. And tomorrow as well, we will have our session on graphology, which changes life. Many we are not aware of it, so please join us to know what graphotherapy means, and making conscious changes in your handwriting to bring about positive changes in your personality. And this is something I'm sure you can change now also. When you are a professional, you want some changes. So it's a very interesting topic, something very new to all of us. So please join us tomorrow from 12 to 1 p.m. The same link. And if you have any questions, do email us at webinar@letustalkit.com. And definitely we have our session, our youth session, Let Us Talk It Youth Series. And in that we have our topic of mastering your EQ, the emotional quotient, and how we can use that to change our intra and interpersonal relationships. So that's also a very different topic. We do not give that much of thought in it. It's always people are running after IQ, but yes, EQ does make you complete. So with that session, we'll be there. The youth will be there from 4 to 5 p.m. EST. So coming back to today's session, any more questions, comments, feedback?
Yeah, that was a great session. Thank you so much for all the deep technical insights. So that, yeah, appreciate that, Manthan. Yeah. So Julian, just to add to you, we have this weekly public speaking mentoring sessions for youth, which are at no cost, Tuesday and Wednesday 4 p.m. at the same webinar link that you joined now. It is every week, Tuesday and Wednesday, 4 p.m. Eastern Time. And they go live on Friday at 4 p.m. Eastern Time. So that is the schedule for youth. So today, they're going to talk about the EQ. They're going to continue. They had a great session yesterday, and then today they're going to continue. And also we have yoga sessions on Wednesdays and Sundays. Wednesday 9 p.m. Eastern time, and Sundays 10 a.m. Eastern time. And that is one of the very popular yoga sessions. Usually the online yoga is, it doesn't seem so interesting and appealing. But I think, if the attendees are there in this group, they will know this is a great yoga, teacher that really impressed all of us. So that's on Wednesdays and Sundays.
Yeah, sure, I will be happy to join.
Okay, thank you all.
Thank you, Srini. Yeah. Yes. So a lot of things going on. If you are interested, if you know somebody is interested, please pass on the information so that every one of us can benefit, enjoy, and look life a little differently than mundane everyday
Sorry,
life.
actually, there is no end to these topics. There are so many things going on. There is also, I want to add that there is another youth initiative, a startup, in gaming, backed by some experts. That's also in progress. It is all about online gaming. So that's a startup initiative where we want to involve youth as well. So yeah, thank you. That's all from me for now.
So if I give Srini a chance, Srini can have a full webinar on only the projects he has in mind. So 1 hour on that itself. His
Srini,
mind just works crazy. Sorry, Nagendra, go ahead.
Srini, Nagendra, yeah. So is it gaming in the sense like, is it starting from programming kind of thing, or is just a regular session?
Yeah, it has a wide scope actually. We are going to have one webinar to parents about unfortunately, it has to be paid webinar, $10 per session on that. So, but that it talks about the myths about, when you, your kids play, mobile games, is it all bad? That is number one. And also how you can develop relationship with your kids and youth, the parents, So by playing along with them, that sounds silly, but yeah, that is one. And then another one is the classes for online gaming. That is another track. And another track is the actual startup itself, where we are also looking into the serious gaming, and which has connected with some kind of a social activities and even social causes. There is a variety of things being discussed actually. So yeah, if anybody is interested, always get in touch with Julan. And
sure, definitely. Yeah. Thank you, Srini.
Right. Yeah. Okay. Thank you.
Srini Garu, this is Kanti Andy.
Yeah, Kanti.
Quick question. So is this, these seminars, these webinars, right? These are only IT related, right? Are there any engineering related ones also?
Oh, that's a great point. Actually, we have, speakers who are in engineering as well, but we haven't really done anything till now. Yeah, but if you have any ideas, yeah, we would love to do that. So,
Okay.
Yeah.
Sure. Yeah, I'll connect with you on the side then.
Even if you want to start with one, that would be great.
Yeah.
Srini just took away my point. Yeah, please.
Okay. Yeah, I wasn't sure, if the audience are just IT, from IT background or other backgrounds, then yeah, maybe,
it's all about work and life and, youth. So it's like a really mixed audience on multiple topics. And so it will be interesting to have Dr. Kanti, who is an engineer, to talk about engineering.
Okay, sure. Yeah. Thank you.
And thank you, Nagendra, Deepa, and Sudhagaru. Nice having a chat on this platform. It's like a reunion, almost one or the other weeks.
Same here, Srini.
Yeah. Absolutely, I'll take this opportunity to thank Manthan. I know it's not something that you were very comfortable, but what I like that you were very confident and you were so interested to, present what you have and what you are passionate about. And I think you did a great job. Thank you, Manthan, for your time, effort. Absolutely. The same here. And thank you so much, audience, for joining in, giving your feedback, comments, asking question, and that interaction that we always crave for. That makes our webinars a success in itself.
Julian, I have to add one line over here.
Sure.
Please, anyone have any kind of doubt, please let me know on Twitter. My Twitter handler is Manthan Ladwa. So please come with so awesome question or any type of questions. I will be happy to answer. Like Nagendra's question was one of the awesome questions I have ever had, and which was very curious for me, like as well. So I will be happy to answer any of the questions. If anyone wants to connect with me, please connect with me on LinkedIn or Twitter. It's fine with me. I will be happy to help in any case in machine learning. I will be happy to help. Thank you.
Absolutely. Thank you, Manthan. Thank you everyone for joining in. And we hope to see you again tomorrow. Trust me, tomorrow's session will be different and it will be interesting. Thank you, everyone. Have a great day. Thank you. Bye-bye.
Bye.
Bye-bye.
Bye.